Okay, hi, selamat sejahtera. Okay, so today we will continue our chapter 7. We will cover subtopic 7.3, which is principle of conservation of energy. Okay, as we can see there, principle of conservation of energy. Okay, so let us recap. You have learned, okay, you must memorize 5 formulas, okay, from our previous lesson, okay, which is starting from the 7.1. We already covered the formula, which is W is equal to Fs. Okay, so work done is equal to force times displacement. Okay, don't forget the unit for the work is in joule. Okay, work, W is work, is equal to F, which is force. Okay, the unit is Newton, and S is displacement, which is in meter. And second one, we cover the formula, which is P is power. Okay, the unit of power is W. W, which is watt, equal to W, which is work done. Okay, in joule, we already know the formula for the work. Now we substitute the work done inside the formula for the power. Okay, so which is P equal to W over T. W is work, okay, which is in joule, and also T is time taken, which is in second. Okay, so don't forget. So if question give you minutes, you must change it to second. And after that, we learn about the potential energy and kinetic energy, which is potential energy. There is two type of potential energy. Number one is the gravitational potential energy. Okay, which is the formula is GPE is equal to mgh. Okay, so m is mass, which is in kg. G is gravitational acceleration, which is m over second, and also the h is also height, which is the unit is meter. And the second one for the potential energy is elastic potential energy, which is involved the stretching or compression force. Okay, so equal to 1 per 2, 1 over 2 Fx. So force for F is stretching, either you stretch or you compress. Okay, so the unit is in Newton. And also times X, which is X is the displacement from the equilibrium position. Okay, so the unit is in meter. Okay, and the last one is Ke, which is kinetic energy, is equal to 1 over 2 mv square. Okay, so sorry, wrong here. Okay, wrong from I put wrong. That is F. Supposedly that is M. Okay, so M is equal to mass, which is in kg, and V is velocity, which is the unit is m over second. Okay, so that is 5 formula you must memorize and you must remember. Okay, so if you can understand the formulas, and easy for you to substitute all the information inside the formula, so easy for you to answer the question. Okay, so now let us continue our subtopic 7.3, which is principle of conservation of energy. Okay, so at this end of this lesson, a pupil is able to explain the example of the principle of conservation of energy. Okay, number 2, solve qualitative and quantitative problems involving the transformation of kinetic energy and potential energy in a closed system. Okay, what is closed system? Later, teacher will explain it to you. Okay, next. principle of conservation of energy. Okay, the principle of conservation of energy state that, okay, remember, state that energy cannot be created or destroyed, but only be converted from one form to another form. Okay, it cannot be created or destroyed. Okay, it only can convert from one form to another form. Okay, so that is the concept of the principle of conservation of energy. Okay, so conservation of energy is the term used to denote change in energy from one form to another. Remember, okay, it cannot be created and also destroyed. It only be transferred from one to another. Example, burning candle from the chemical energy will transfer to the heat and also light energy. Okay, so from our previous chapter also we have learned about the electric energy. Okay, so which is when you switch on the light. Okay, when you switch on the light, okay, so from the electric energy it will convert to the heat and also light energy. Okay, so fuel here from chemical to heat, and also after that it transfers to the kinetic energy, and lastly it will produce electricity. Okay, nuclear explosion, nuclear energy to the heat and light energy, and spring elastic potential energy, either you stretch or you compress, it will transfer to another energy, another form of energy. We call that kinetic energy. Okay, so a conservation of energy, the potential energy will decrease and transform into kinetic energy. So from this one, you can see the example here, the application of the concept of the principle of conservation of energy is roller coaster. Okay, so by conservation of energy, the potential energy will decrease and transform into kinetic energy. Okay, so from this roller coaster, you can see that the potential energy involved is gravitational potential energy. Okay, so if the roller coaster at the top of the hill, so the GPE, gravitational potential energy, is the greatest, okay, at the top of the hill. Okay, so as it starts to descend, the cart loses the potential energy and gains kinetic energy. So when the roller coaster has just passed the first valley, it has a lot of kinetic energy. So it can climb up the second hill. By conservation of energy, it can climb up to a height equal to that it went down before. Okay, so that is the conservation application of the principle of the conservation of energy. So if the potential energy is greater, is higher, okay, so the kinetic energy will be lower. Okay, so when the potential energy start lower down, okay, and after that the kinetic energy will increase. Okay, so like that. Okay, so that's why we know that the principle of conservation of energy stated that energy cannot be created or destroyed. It can only be transferred from one to another. Okay, so the conservation of energy, sorry, wrong spelling. Okay, example is kinetic energy to the potential energy to the kinetic energy. Okay, so the application is roller coaster, as teacher explained to you, and after that falling object. Okay, so this one is refer to your textbook, page 223. Okay, so this one you can see here, oscillating system obey the principle of conservation of energy. Okay, so oscillation of a simple pendulum. All right, so look here at position X, okay, position X. Okay, so the pendulum, the bob will start, which is static. Okay, the gravitational potential energy is at the maximum because the bob at the maximum height. Okay, so you can see that the bob at the maximum height. Okay, however, the kinetic energy is zero because the pendulum has not started yet. Okay, so zero, which is the bob stationary and the speed is zero. Okay, so and after that, when the bob start to move from position X to the Y, the gravitational potential energy of bob is decreased. Okay, so you can see that the gravitational from the at the maximum height, okay, it will start decrease. Okay, but the kinetic energy of the bob will increase. Okay, so you can see if the gravitational potential energy decrease, the kinetic energy of bob will increase. Okay, because the speed of the bob increasing. Okay, so that is from X to Y. X position Y, okay, at position Y, the gravitational potential energy is minimum. Okay, maximum at X, and after that we'll go through at Y, which is minimum. Okay, so because bob at the minimum height and the kinetic energy at maximum. Okay, so bob at the maximum speed. Okay, okay, at the maximum speed. Okay, so that from the position Y to Z, okay, you can see the gravitational potential energy of bob is increased. Okay, so bertambah, semakin meningkat. But the kinetic energy of bob will decrease. Okay, it's difficult for bob to to be at the position of Z. Okay, so as the gravitational potential energy of bob is increasing, the kinetic energy of the bob will be decreasing because the speed of the bob will decrease. Okay, so at position Z, the gravitational potential energy back to the maximum height again, and the kinetic energy will be zero because the bob is stationary, static, and the speed is zero. Okay, then the bob will continue moving from Z to Y. The GPE, the gravitational potential energy of bob will decrease. Okay, at the maximum to the minimum, and what happened to the kinetic energy will increase and the speed will increase. Okay, so at position Y back, okay, same. Okay, so the GPE minimum and the speed and the kinetic energy is maximum. Okay, from Y to X, the gravitational potential energy increase. Okay, increase, and kinetic energy decrease because the speed also decrease. Okay, and back at position X, the gravitational potential energy will be maximum. Okay, at the maximum height, and kinetic energy is zero. Okay, so that is the oscillation of a simple pendulum. Okay, so that one is referred to the gravitational potential energy. Okay, so as we know that there is two type of potential energy, which is gravitational potential energy and also elastic potential energy. Okay, now we refer to the elastic potential energy. Okay, so look here at position X. Okay, you can see here the equilibrium position is Y. Okay, So at position X, okay, you are stretching the spring, okay, so that the load will be lower. Okay, so elastic potential energy is maximum because spring is more stretched, and the kinetic energy is zero because spring is stationary and the speed is zero. Okay, so next, the act from X to Y again. So the elastic potential energy will decrease because it will back to the equilibrium position. Okay, it will less stretch, and the kinetic energy will start increase because the speed of the spring increasing. Okay, at position Y, the elastic potential energy will be minimum because that is the equilibrium position, and the kinetic energy maximum, okay, because the speed of the spring at maximum. Okay, and after that, from position Y to Z, elastic potential energy will increase. Okay, so because spring is gradually becoming more compressed, okay, from Y to Z, and the kinetic energy will decrease because speed of spring decreasing. Okay, so vice versa, same goes with X to Z, from Z to Y, and also Y to X. Okay, so you can read from your textbook, page 224. Okay, so look here. At the position A, you can see there, the position A, you can see, okay, so this one is referred to the gravitational potential energy. Okay, this one is not the elastic potential energy. Gravitational potential energy will be at maximum height. You can see the A, it's at maximum height. And the kinetic energy is zero. Okay, so GPE maximum, the kinetic energy zero. As it start to move to B, okay, so the GPE will be half, and also the KE also half. Okay, and at the position C, okay, the GPE will be at the minimum, and the kinetic energy, the speed is increasing at the maximum. Okay, so it will just transfer from one to another. Okay, next, this is very important. Okay, what is the closed system? Okay, so look here, transformation of kinetic energy and potential energy in a closed system. Okay, so what you can see here is the total energy will be constant in a closed system. Again, in the closed system will be constant. Okay, what is closed system? Closed system means it is not influenced by any other energy. Okay, so that's why we call that constant. Okay, to obey the principle of conservation of energy states that energy cannot be created or destroyed. It can only transferred from one to another. So total potential energy and kinetic energy is constant. Okay. So example of the numerical problem from your textbook, page 226. Okay, so you can see here. Read the question. Okay, from figure 7.14 shows a toy pistol. The length of the spring in toy pistol is 300 millimeter. If a force of 5 Newton is used to compress. Okay, remember, compress. Okay, so if that is compressed, that one is referred to the elastic potential energy. Okay, so calculate the maximum speed. Okay, so maximum speed will refer to the velocity. Okay, and of the plastic ball of mass 50 gram when it is fired from the pistol. state an assumption that is made in solving this problem. Okay, so as teacher put there, okay, compress, you refer to the EPE. So how you want to do the solution? Okay, based on the principle of conservation of energy, elastic potential energy stored in the spring is equal to the kinetic energy of the plastic ball. So that just use the formula of the elastic potential energy equal to the kinetic energy, and after that substitute all the information in the formula. But don't forget to convert, okay, to convert the unit, okay, to the unit. Example like 250 millimeter, you must convert it to meter. And example like the 50 gram, you must convert it to kilogram. Okay, then after that you just continue with the calculation. Okay, so the exercise from your formative practice. An oscillating loaded spring, as shown in figure 1, is a closed oscillation system. State the position of the load where the elastic potential energy of the system is maximum. Okay, so maximum at P and also at R. State the position of the load when the elastic potential energy of the system is minimum. That is the Q, which is at the position of the equilibrium position. Okay, so just proceed with your homework. Okay, boys, so that's all for today. Take care, stay safe, stay healthy, and stay at home. And hopefully you can really understand about the principle of conservation of energy.
A roller coaster ride is a fun and exciting experience for many. It can also be the best example to explain the principle of conservation of energy. The principle of conservation of energy states that energy cannot be created or destroyed, but can only change its form. In a roller coaster, the greatest potential energy is at the top of the first hill. As they start their descent, the cart loses potential energy and gains kinetic energy. Throughout the ride, each time a cart loses its height, it gains speed as potential energy is transformed into kinetic energy. Likewise, each time it gains height, it loses speed as kinetic energy is transformed into potential energy. Another example